I am solving the last question, which is question 23 from the GCE past paper, which was written in August 2024, Math Paper 1. Question 23 reads, the diagram below shows the speed-time graph of an object. The object accelerates uniformly from O to P until it reaches a speed of 20 meters per second in 4 seconds, and then moves steadily from P to Q for 6 seconds and finally comes to rest. Find the A. Acceleration in the first 4 seconds, B. Total distance covered by the object, C. The average speed in the last 4 seconds. I am answering question 23A. I want to find the acceleration in the first 4 seconds. We need to use the formula for acceleration, which I'm writing. Okay, so we use this formula for finding the acceleration. So we have velocity. The velocity at the V sub f is the velocity at the end of the time period, and V sub I is the velocity at the beginning or the start of the time or the interval. This interval. Then we have the final time or the time at the end of the interval, and T sub I is the time at the beginning or start of the interval. So what interval are we talking about? The interval from O to P. So the interval from O to P, the initial velocity is 0, and this object is starting from rest, meaning it is starting from time 0. What is our final velocity? Our final velocity is 20. What is our final time? Our final time is 4 seconds. So when we substitute those values in this formula, we'll find, what am I doing? No. So the final velocity in that interval is 20 minus the initial velocity. We started at 0. The final time is 4, and we started at time 0. So 20 minus 0 is 20. 4 minus 0 is 4. 20 divided by 4 is 5 meters per second squared. So that is our acceleration. We look at total distance covered by the object. The total distance covered by the object is the area below the speed time graph. And the area below the speed time graph is a trapezium. So we are going to find the area of a trapezium. The distance is the area of a trapezium. So distance is equal to now this is the area of the trapezium. Now A is PQ, this distance PQ, and B is the other parallel side of the trapezium, which is from O to 15. So the length PQ is 6 seconds. 10 minus 4 give us 6 seconds. Then my B, which is the other parallel side, is 15. What is the height of this trapezium? It's from O to 20. I will substitute those values in my formula. Two divided by 2 is 1. 2 divided by 20 is 10. 20 divided by 2 is 10. Oh, what's going on? Okay, so we have 1 multiplied by, this is 21 multiplied by 10. This gives me a total distance of 210 meters. I will be answering question C, that is 23C on the next slide. Okay, so we need to find the average speed in the last 4 seconds. So when you look at the diagram, from 10 to 15, that is the last 5 seconds. We want the average speed in the last 4 seconds. So for us to get 4 seconds, I think we need to move 1 more second from 10, and we are going to have 11. So 15 minus 11 will give us 4 seconds. So what they want us to find is the average speed in the last 4 seconds. Last 4 seconds. So we know that average speed is given by the total distance covered in the required time or in the required interval over the total time taken in that interval. So the total time in that interval from 11 to 15 is 4 seconds. The total distance should be, okay, it's not a perfect triangle, but should be the area of this triangle. Area of this triangle. What we don't know is the height of this triangle. The height of this triangle. So I'm going to call the height of this triangle V sub I. We don't know the height of that triangle, which is V sub I. Now, in order to find V sub I, we have to take advantage of that point there. That point lies on this line. This line will have a slope. or we can say it will have a gradient. So this point and that point and any point that lies on this line will have the same gradient, the same slope. And we know that the slope or gradient of this line is the acceleration. Acceleration, or we can say deceleration. Deceleration. Mind my spelling. So we need to find the deceleration of that line. Once we find the deceleration of that line, everything will be smooth. So we're going to use the same formula that you saw earlier on. We are going to have an initial point there and a final point. We take the initial point and the final point. We find the velocity, the initial velocity. It is 20. The initial time there will be 10. The final velocity right here is 0. It is 0. Then the final time is 15 seconds. So we use these values to find the deceleration of that line. So final velocity is 0. Initial is 20. Final time is 15. Initial is 10. When we subtract these values, we are going to have negative 20 over 5. So the acceleration is a negative 4. I am back at what I said before. So we have a slope. We have a gradient. We have a gradient. So we know that at this point, the gradient is the same. So we're going to take advantage of using the gradient here to find what V sub I is. We use the same formula, but this time we're going to get the initial point. That will be our initial point there. Our initial point has initial time. In fact, it has initial velocity, which we don't know, and initial time, which is 11. Then we're going to get the final velocity, which is at this point. The final velocity is 0, and we are going to get the final time, which is 15. We already know what acceleration is. The acceleration is the gradient of this line, which is negative 4. So we're going to substitute all these values in this formula in order for us to find VI, which is the height of this triangle. The reason why we're finding the height of this triangle is that we want to find the area of this triangle. The area of this triangle will give us the total distance. So let's find V sub I using this formula. We substitute all these values in that formula. We simplify. we cross multiply. We multiply negative on both sides. So we have found our initial velocity as 16. So we now are going to find the area of this triangle. Remember that the base is 4 because this time interval lasts for 4 seconds. The area of a triangle is given by half by base by height. Half by 4 by 16. 2 divided by 2 is 1. 4 divided by 2 is 2. So the distance covered in this interval will be 32 meters. The total distance covered in that interval will be 32 meters. Therefore, the average speed is equal to 32 meters divided by 8. No. Divided by 4 seconds. We're going to have 8 meters per second. 8 meters per second.